Welcome to the fourth submodule of the Copernicus Land Monitoring Service, which provides information on a specific product from the Copernicus local component, the Natura 2000 dataset, and also related assessments that are done on top of that product. So as a starting point, I'd like to give some information on the Natura 2000. Basically, this is the European ecological network of protected areas, and it's, for the European Union, is a key instrument for biodiversity protection. It is based on two directives, basically the Birds Directive and the Habitats Directive, which constitute these protected areas. They have planned and arranged such as to have a spatial and functional connectivity to allow both species and biodiversity hotspots to stay in interaction and to exchange, and thus allow the populations of the species there to stay healthy. There's a lot of information on that on the web, so I've given you just two addresses that you may want to contact for further information. Basically, the task of the assessment that has been undertaken as part of the local component of the Copernicus Land Monitoring Service was to monitor the stability of those Natura 2000 sites, specifically with respect to the conservation and preservation of valuable grassland areas. So basically the task was to assess the effectiveness of these protected areas in terms of halting the decline of these related habitat types which relate to specifically grassland. This exercise is meant to also support and facilitate further work on activities for biodiversity monitoring, thereby focusing not on all of the Natura 2000 protected areas all over Europe, but on a selection which have specific semi-natural or species-rich grassland habitats in a certain quantity. The task comprised to map and monitor the land cover and the land use at 2 points in time, in 2006 and in 2012, see which changes have happened in between, and not only in the direct area of these protected sites, but also in a 2-kilometer buffer zone around these sites to be able to assess the impacts that are exerted from the surrounding towards that core protected areas. In that buffer zone, the task was also to assess pressures and threats that do impact on the core areas, and in the core areas to assess the changes that have happened to grassland, what were the causes, which directions the changes have been to, and so on. So the product that was basically to be mapped was the land cover land use product of the Natura 2000, which is following a nomenclature based on the MAS concept, which means mapping and assessment of ecosystems and their services. This is a hierarchical nomenclature, as you can see on the right, comprising 10 different basic classes of land cover and land use, which are then further split up down to level 4 with about 62 different classes, so a lot of detail. This nomenclature is very important, is largely compatible with other European data sets of land cover and land use, like Corinne Land Cover, the Urban Atlas, and also the riparian zones dataset, which allows also to a large degree synergistic use of these different data. The data are arranged in vector format, so they're polygons with a minimum mapping unit of 0.5 hectare, both for the time steps 2006 and 12 and changes in between. The minimum width of these objects, of these polygons, is 10 meters, and the overall accuracy that these products do have is 85% for the status layers of 2006 and 12 and 80% for the change areas. Data used as inputs for creating these datasets were manifold. On the one hand, satellite imagery that were available in the frame of the Copernicus data warehouse that's run by the European Space Agency, ESA. So there was a data set available in a pan-European fashion with 2.5 meter spectral resolution, plus additional scenes from Pléiades, which have a slightly higher resolution. There were additional thematic data that were used also, and that were riparian zones and urban atlas, so the other local components of the Copernicus land service, plus Korean land cover, the high resolution layer from the medium or from the high resolution component, plus other freely available datasets like OpenStreetMap. In terms of methodology, it was not just a simple classification, but it was really a visual image interpretation on screen and digital delineation of the land cover and land use polygons by experienced image interpreters that really dealt with interpreting these datasets in much detail with all the experience they had. Right, as I said, it's vector data with minimum polygon size of 0.5 hectare. Can be bigger, of course, also. So here's few examples of how you have to imagine these Natura 2000 sites. On the left side, there's one example of the inner core area of Natura protected sites. That's just these inner polygons here, and the buffer zone around that. So this is close to the city of Regensburg in Germany. And you see in more zoom in detail these inner core areas, which are rich in semi-natural dry grasslands on specifically calcareous substrates. So it's limestone underneath, basically. And there's also areas with lowland hay meadows, which you can see here along the river Danube. The final product that has been mapped may look like this one. This is an example along the Elbe River, and you see just the nomenclature also presented on the left-hand side. So these are the 62 classes on the 10 main level 1 categories, split further down to level 4. And you see that this provides a lot of different classes and representation in a spatially explicit manner. If we zoom further in, you can see that the character of the product is basically unlike a coarse classification, but it's more like really a cadastre type, really. It's really sharp edges, sharp boundaries, not fuzzy, but clear, decided and clear delineated boundaries. If we go further in and just focus on areas that have been actually changing. So this is in the orange boxes here. You see there's the polygons which show a certain color here, which do represent changes between 2006 and 2012. And if you go further in, we see what has happened. Like in 2006, there used to be several presumably coniferous forest stands, which have been converted to grassland areas in 2012. So from an ecological point of view, from a grassland point of view, that's a good development. So that's something you would really like to see. Abandonment of commercial forestry activities going to more valuable grassland areas. Another example of a human-induced change is an active gravel pit area, which is shown on the left side for 26 and on the right side for 2012. So you can really see how the gravel extraction has moved and progressed, like here, which has grown, and here also. So this is to be expected, of course. And when you look at the changes, you see that the classification has correctly captured these changes which have happened over time. So another example for a change is in urban areas, which is also very typical. At the fringe of urban settlements, you have a newly built up land. So 26, there used to be cropland and grassland in that yellow marked polygon, and in 2012, you see this has been newly built up with residential area. This is, in terms of ecological perspective, of course, not preferential. Overall, if you look at the vector data and how they're represented, you have both the 2012 and the 26 information and the changes represented in one vector polygon file, differently attributed with different attributes, so that you can visualize that, for example, here by striped overlays which do represent the changed areas. These data are freely available from the EA's web portal of the land monitoring service. So this is an example, a screenshot of the portal. The address is also given here. There you can access the data both as a viewing service or as a download service, or also as a web map service which you may integrate into your GIS environment. In terms of what you can further do with the data, I mentioned before, one of the tasks was also to assess in how far these changes have had influence really on the inner core areas. And That was done by an assessment of the pressures and threats that are exerted from the buffer area on the core areas. Basically, it identified the general processes and the trends on a landscape level that impacted really. And for deciding on which changes represent which kind of pressure or threat, there was an adjusted land cover change pressure association matrix used. So that's a concept from ecology. And the most relevant pressures considered were really urbanization, agricultural intensification, which can be on the cost of grassland areas, afforestation, so new forest being planted, deforestation, which is also a quite common change, abandonment of land, for example, due to unprofitability of certain use patterns, and drainage, so have land basically drained from water. And of course, also the opposite processes can occur, so not only pressures, but also relaxations. So if something is converted to the better, also that happens, however, to a minor degree. To come to a balance, of course, that needs to be considered also. So here's one example of one of these pressures that have been assessed, specifically agricultural intensification. You see on the left-hand side, there's an overview image where the assessed Natura 2000 sites are just shown here, and you see that the legend shows that this pressure typically is in ranges of between 0.5% of the changes and up to maximum 5%. So, but this is relatively uncommon. On the right hand, you see different Natura 2000 sites and the different levels of that agricultural intensification pressure being present in these sites. And you see this is quite a heterogeneous situation. So overall, the finding was that the effects that led to such pressures being present were shrub encroachment. So you have on several areas, because of that abandonment of certain agricultural practices, you have shrubs entering, invading former agricultural or grassland areas due to land abandonment, which is one of the drivers of that. There can be overgrazing. So when you have too many cattle on an area, of course, the quality of the grassland is deteriorating. You have urban sprawl, which leads to increase of the settlement areas. And you have also partially conversion from more natural or semi-natural land cover types to agricultural, to arable land. In summary, and this is my last slide, what we found, or what has been found, is that the Copernicus Natura 2000 sites show a certain degree of agricultural intensification. That was really the main pressure there. And there were also others present to a minor degree, like increasing area consumption by the settlements, grassland abandonment and shrub encroachment in decreasing order of magnitude. But in general, and that was the positive outcome, the decline of grassland was found to be really smaller than expected. And moreover, the protective effect of Natura 2000 sites has really been proven for the areas that have been assessed. So inside the protected areas, the protective effect for grassland habitats was significantly higher than in the buffer areas or outside, which is a good sign. Thanks for your attention.